Okay, so in this lesson, we're going to continue with moles, but we're going to see why or how moles can be used and why they are needed when chemists are carrying out a chemical reaction. Okay, and we're going to first look at a chemical reaction. And to do this, I'm not going to give you a real reaction. I'll explain why in a second. I'm just going to make up elements. So I'm going to use A, which is not a real element, plus B, and when A and B react together, they make AB. Okay, so this is my chemical equation. I'm reacting A with B and I'm making AB. Okay, I need to make sure my equation is balanced. I've got one A on the left and I've got one A on the right, so that is balanced. With B, I've got one B on the left, one B on the right, so it is already balanced, and I've got my chemical equation. A plus B makes AB. Okay, I'm going to draw this, okay, and I'm going to draw atom A, and I'm going to assume that atom A is quite a small atom. And then I'm going to draw atom B, and I'm going to make atom B a bit larger, okay? And this is true of all elements, okay? Elements on the periodic table are not all the same size, okay? So if we look at lithium up here, okay, this number 3 tells me that lithium has only 3 protons and 3 electrons, okay, so 3 electrons. Whereas if I look down here at iodine, it's got 53 protons, 53 electrons, okay? So as you go down the periodic table, your atoms get bigger and bigger and bigger and bigger, okay? So I'm just going to show that in my diagram. I'm going to have element A, or atom A is quite small, and I'm going to react it with element B. And then I'm going to make my product AB. So I'm just going to draw A and B together, okay? And that's going to be my AB. So if I was actually doing this reaction, okay, I can see from my equation that if I have one atom of A, okay, I need one atom of B. Okay, if I've got one atom of A, I need one atom of B, because they react in a ratio that is 1:1. For every A, you need a B so that you can make AB. That means if I had 10 atoms of A, I would need 10 atoms of B. Okay? And if you had 1,000 atoms of A, you would need 1,000 atoms of B. 1,000,000 atoms of A, you would need 1,000,000 atoms of B. My equation tells me that for every A, I need a B so that I can make AB. So I need to have the atoms present in equal number. If I had 1,000,000 atoms of A, I would need 1,000,000 atoms of B. Okay? So when I go to actually carry out this imaginary reaction, because these elements don't actually exist, okay, if I was to go carry out this reaction and I had element A, okay, when you have an element in the lab, you don't know how many atoms you've got in it, okay? On the bottle that you keep chemicals in, it doesn't say the number of atoms, okay? It always gives you the mass. We always deal with, when we're dealing with reactions and we're dealing with chemicals, we always put them on the mass balance and we get their mass, okay? So to say I wanted to carry out this reaction, and I know I'm going to react A and B to make AB, and I decide I'm going to start, I'm just going to write the equation underneath again, A plus B. And I decide I'm going to use 15 grams of A. That's how much of A I'm going to use. And now I need to know how much B do I need to react with A. Okay? The obvious thing to say, well, if you need 15 grams of A, then you obviously need 15 grams of B, because you need to have them present in the same amount. Okay? But that's not correct, and I'm going to show you why, because that's the obvious thing to say. If I've got 15 grams of A, I must need 15 grams of B, because I need them present in the same amount, okay? But we're going to look at why that is incorrect, okay? So when I was drawing atoms A and B, I drew atom A really small, and I drew atom B really big, okay? So now I'm going to put like imaginary mass values on A and B, and I'm going to say that each atom of A has a mass of 3 grams. And this is ridiculous. Atoms are tiny. No atom has a mass of 3 grams. Okay, atoms are absolutely minuscule. And I'm going to pretend that atom B has a mass of 5. Okay, So if I am starting my reaction with 15 grams of A, okay, in order to have 15 grams of A, each one of them has a mass of 3. I must have 5 A's altogether. Okay, if I've got 15 grams of A, I must have 5 A atoms altogether because each one has a mass of 3. Okay, and if I react to that, so this is going to be 15 grams of A. If I react 15 grams of A with 15 grams of B, okay, if I look up here, I see that each B is 5 grams. Okay, so if I want 15 grams of B and each one is 5, then I'm only going to need 3 B atoms to get 15 grams of B. Okay, so the way I've done this here with an equal mass, 15 grams of each, that means I've got 5 atoms of A and 3 atoms of B. Okay, and when we did the original chemical equation, we saw that for this reaction to work, you need equal numbers of atoms. So if I have 5 atoms of A, I need 5 atoms of B. Okay, because each A will pair up with a B. So an A will pair up with a B, an A with a B, and an A with a B. And by doing, I've drawn 6. There's only supposed to be 5 there, okay? An A will pair with a B, an A will pair with a B, and A will pair with a B. And then you're left with 2 A atoms left over. There are going to be 2 A atoms that do not have a B to pair up with. And these atoms are just going to be wasted. Okay, I know it doesn't seem like a big deal right now on the small scale to waste 2 atoms, but when you're carrying out reactions in industry and you're using tons of chemical reactions, so you're not just weighing out grams, you're weighing out your reactants in tons, it matters. It matters if you don't have the equal quantities that you need. It matters if you're wasting. Okay, so you need to have the right quantities for your reaction. And if I'm using an equal mass of both A and B, I am not using an equal number of atoms, and some of my atoms of A are going to be wasted. Okay, so I'm just going to summarize this by saying equal masses, so having them both at 15 grams does not mean you got an equal number of atoms. Okay, for this chemical reaction, we need an equal number of atoms. If you've got 100 atoms of A, you need 100 atoms of B. If I just use an equal mass, so in this case 15 grams of each, as you can see, I do not end up with an equal number of atoms. Okay, so when I'm doing my chemical reaction, I'm not just going to use masses. Okay, I'm going to need to use something else. I'm going to need to use moles. Okay, and if you remember from the last lesson, okay, we saw that the word mole is the number 6.02 by 10 to the 23. And we did a couple of calculations, okay? And we saw, okay, just imagine for a second, I had 2 moles of A, okay? If I had 2 moles of A, I would have 2 multiplied by 6.02 by 10 to the 23. I would have 2 by 6.02 by 10 to the 23. I would have 1.204 by 10 to the 24 atoms of A. And if I had 2 moles of B, I would do the exact same calculation, okay? I'm filling in the number 6.02 by 10 to the 23. I fill that number in for the word mole. It's still going to be 2 multiplied by the same number, which is going to give me the same answer. So if I have equal numbers of moles of A and of B, then I will have the same number of atoms. Okay, so equal masses, 15 grams of each, does not mean I've got an equal number of atoms, but equal number of moles does mean I've got an equal number of atoms. And for this chemical reaction, I need an equal number of atoms. Okay, so I'm going to flip over the page, so pause if you need to. Okay, I'm going to flip over the page and I'm going to write if you have an equal number of moles, then you do have an equal number of atoms. Okay, equal number of moles, you've got an equal number of atoms. Okay, it'd be the equivalent of me saying to you, if you had a kilo of shoes and you had a kilo of socks, okay, shoes are heavier than socks. So if you had a kilo of shoes and a kilo of socks, because shoes are heavier, you would have less shoes in your kilo of shoes than socks. Okay, you'd need loads and loads and loads of socks to make it up to a kilo of socks. Shoes are much heavier. You wouldn't need that many shoes to have a kilo of shoes. So if you have an equal mass of shoes and socks, you do not have the same number of shoes and socks. But if I said to you, you've got 8 pairs of shoes and 8 pairs of socks, a pair means 2. 8 times 2 is 16. You've got 16 individual shoes. You've got 16 individual socks. Okay, it's the same here with elements. Equal number of masses, you don't have the same number of atoms, but equal number of moles, and you do have an equal number of atoms, okay? And we're going to look at a real chemical reaction now so we can see this in action, all right? I'm going to write Fe, which is a symbol for iron. And I'm going to react iron with S, which is a symbol for sulfur. And when iron and sulfur react, they form iron sulfide, which has the symbol FeS, okay? Iron and sulfur forms iron sulfide. Okay, if I go to balance this equation, I've got 1 iron on the left, 1 iron on the right, so that's fine. I've got 1 sulfur on the left, 1 sulfur on the right, so that is fine. So just like my reaction on the previous page, my made-up reaction between A and B, I have got a 1:1 ratio. Okay, and that again means if I had 10 atoms of iron, I would need 10 atoms of sulfur. If I had 1,000,000 atoms of iron, I would need 1,000,000 atoms of sulfur for this chemical reaction to proceed with no waste. And I don't want waste. Okay, again, if I'm going to carry out this reaction in the lab, okay, I go to the storeroom, I get my chemicals, okay, and I look at the box, the container with the iron, and it's not telling me how many atoms, it's telling me grams. Okay, don't measure the number of atoms in the lab. You always measure in grams. So I decide I'm going to carry out this reaction. I'm going to carry out this reaction with 30 grams of iron. Okay, and I want to know how much sulfur am I going to react with the iron. Okay, and again, I've said here there's a 1:1 ratio, so that kind of the impulse is just to go, right, if it's a 1:1 ratio and you need an equal amount of each, 30 grams of iron, 30 grams of sulfur, okay, but that's not right, okay? The reason it's not right, if you look at our periodic table, iron, okay, here, 26 electrons, 26 protons, sulfur's only got 16. Iron is much bigger than sulfur, okay? And if you've got 30 grams of iron and 30 grams of sulfur, you don't have an equal number of atoms, okay? So what you're going to need to do is you need to go to moles, because once you go to moles, you can figure out the number of atoms, okay? So you are going to go from grams to moles, okay? Because if you've got an equal number of moles, you do have an equal number of atoms. So we need to get from grams to moles. Okay, and when we do these equations or these questions, I always draw myself a little table because I think it makes it really easy to lay out the information. Okay, so I'm going to draw this in a table right now. Okay, I've got iron and I've got sulfur. I'm reacting the two of them together. And in my table, I'm going to include mass, formula mass, moles, and ratio. Okay, so I'm including the 3 things for my formula triangle, and I'm also including ratio, and I'm including iron and sulfur. They're the 2 things that I'm reacting, okay? The mass of iron, I'm given the mass of iron, okay? I know I'm starting with 30 grams of iron. The mass of sulfur, that's what I'm trying to find out, okay? That's the whole point. I've got 30 grams of iron. I want to know how much sulfur do I need for this reaction. That's what I'm trying to find, okay? Formula mass. Okay, if I look at my periodic table, I will see that the big number next to iron, I'll show you, big number next to iron is 56. Big number next to sulfur is 32. So iron is 56, sulfur is 32. Okay, you can see from my symbol that I've just got one iron. Okay, it's not bonded to anything else. There's no number. Okay, so for the formula mass, I'm just going to be writing down 56. And the same with sulfur. There's no numbers. There's nothing else there. So I'm just going to be writing down 32. Okay, the next line on my table is moles. If you remember your formula triangle, okay, you've got mass at the top, then you've got moles, then you've got formula mass. Okay, if I try to find moles, I cover moles, and I'm left with mass divided by formula mass. In my table, I've got mass, I've got formula mass, so it's just going to be 30 divided by 56, and that equals, 30 divided by 56 equals 0.54 to 2 decimal places. Okay, that's the amount of moles of iron I've got. All right, if I come over here to sulfur and I try and do the same calculation, I'll see that I can't. Okay, and the reason I can't is I don't have mass. All I've got is formula mass, and with just formula mass by itself, I can't calculate moles. Okay, so what am I going to do? I'm going to use ratio. All right, so when I'm talking about the ratio, I look at my balanced chemical equation. Okay, I've got iron and I've got sulfur, and I've said they're in a 1:1 ratio. And the reason I'm saying 1:1 is because there's no number in front of iron. If there's no number, I write 1. There's no number in front of sulfur. If there's no number, I write 1. So they've got a 1:1 ratio. And that tells me that I need equal number of atoms. And if I have an equal number of atoms, I need an equal number of moles. If iron has 0.54 moles, then I need sulfur to have 0.54 moles. Okay, so ratio 1:1. These two numbers are both the same. That means these two numbers both have to be the same. A 1:1 ratio means the number of moles have to be the same. Okay, if I've got 0.54 moles of iron, then I need 0.54 moles of sulfur. Okay, now I've got moles, I've got formula mass, I need to calculate mass. Okay, if I go back to my formula triangle, I see that mass equals moles times formula mass. I've got moles, 0.54. I've got formula mass, 32. So I'm going to write this as 0.54 times 32 equals 0.54 times 32 equals 17.28. Squeeze that in there. 17.28 grams. Okay, and that's my final answer. Okay, if I've got 30 grams of iron and I want to react it with sulfur, I need 17.28 grams of sulfur. Okay, because if I've got these two masses, then that means I've got equal number of moles, and if I've got an equal number of moles, I've got an equal number of atoms. Okay, because if I just show you, because I've got an equal number of moles, okay, so iron has 0.54 moles. Okay, so if you have 30 grams, you've got 0.54 moles. Therefore, it has 0.54 times 6.02 by 10 to the 23. 0.54 times 0.02 by 10 to the 23. It has 3.2508 by 10 to the 23 atoms. Okay, so if you've got 30 grams, you've got 0.54 moles, which means you've got this amount of atoms. This is the number of atoms you've got in 30 grams of iron. You'll see that you've got the same number of moles of sulfur. Okay, so sulfur also has 0.54 moles. So therefore, sulfur also has 0.54 times 6.02 by 10 to 23. Sulfur also has 3.2508 by 10 to the 23 atoms. Okay, because the moles are the same, the atoms are the same. And according to my chemical equation, I need the number of atoms to be the same because they are in a 1:1 ratio. Okay, so I can, by going from grams to moles, I can then go from moles back to grams and find out how much sulfur I would need. Okay, so these questions, okay, I know maybe conceptually it might be a little bit confusing, but these questions are all done exactly the same way. And we're going to do I'm going to do another 2 with you, and then I'm going to give you some to do by yourself. The ratio is not always 1:1, but the questions we're going to do at the moment, I'm going to use a 1:1 ratio until we get the hang of these, and then I will use different ratios. But for the moment, we're going to stick with 1:1 ratios. So I'm going to give you a different equation, all right? I'm going to react HCl, so not an element this time, but I'm going to react it with NaOH. So this is hydrochloric acid. I'm reacting with sodium hydroxide, which is an alkali. An acid and alkali gives me salt and water, which I'm sure you all know. So I get H2O and I get NaOH. Okay, I'm going to balance this. Okay, slightly harder to balance, but I will balance it with you. And what have I done? No, I don't. I get H2 and I get NaCl. Apologies. All right. I've got 1 sodium on this side. I've got 1 sodium on this side. Okay. I have got 1 oxygen here. I've got 1 oxygen here. I've got 1 Cl here, 1 Cl here. And I've got 2 hydrogens here and 2 hydrogens here. So it's all balanced already. I don't need any big numbers. Okay. This is my equation. And in this problem, I'm going to say I have 50 grams of HCl, and I want to know how much NaOH I'm going to react it with. Okay, so in my table, I'm going to put down HCl, and I'm going to put down NaOH, and I'm going to put in mass, formula mass, moles, and ratio. Okay, and I'm going to write down my hydrogen from the periodic table as 1. Cl is 35.5. Na is 23. O is 16. Okay, so these are the numbers that you'll be given in your question. All right, I'm going to start filling in my table. All right, mass of HCl, I'm given this in the question. It's 50 grams. All right, it's right there in the question. That's where I'm getting it from. Mass of NaOH, that is what I'm trying to find. Formula mass, okay, of HCl. In HCl, you've got 1 H and you've got 1 Cl. Okay, so it's going to be 1 plus 35.5, and that equals 36.5. Okay, so I'm doing this from the periodic table. That's where I'm getting these numbers. For NaOH, I've got 1 Na, so it's going to be 23, plus 1 O is 16, plus a hydrogen is 17, and I add that all up together, and I get 40. Okay, so these numbers you are given on your periodic table, although they typically just give them to you in the question, adding them together, 1 H, 1 Cl, 1 Na, 1 O, 1 H. Okay, I'm finding formula mass like I always do. Come down to the next line, and I need to find moles. Okay, from my formula triangle, I can see that moles is mass divided by formula mass. And the way I presented my table, it's really easy because it's this number divided by this number. So you could just draw a divided line there if you want to. It's going to be 50 divided by 36.5. And when I do that, 50 divided by 36.5, I get 1.37. Okay, I can't do that over here, okay, because I don't have a mass. So I'm going to move down to the next line. I'm going to look at ratio, okay. I told you that if there is no number in front of the chemical formula, that you just write the ratio as 1. Again, no number in front of NaOH, so I just write the ratio as 1. Because these two numbers are the same, you've got a 1:1 ratio, these two numbers have to be the same. If this number is 1.37, then this number is also 1.37. These numbers are the same, so these numbers will be the same. Okay, now I know how many moles I need of NaOH, so I can work out the mass of NaOH. So I take 1.37, which are my moles, I multiply it by formula mass, and I get 1.37 times 40. I get 54.8. Okay, and that tells me if I start with 50 grams of HCl, I need 54.8 grams of NaOH. And if I have these two chemicals in these quantities, then I will have an equal number of moles. And according to my balanced chemical equation, I need an equal number of moles because I need an equal number of atoms or molecules. Okay. I'm going to get you to do one or two of them for me. And I'll give you one or two to do for homework as well. So I'm going to stick with I'll stick with the same equation, but I'll change the numbers up slightly. Okay, this time you are going to start with 100 grams of NaOH. And I want to know how much HCl do you need to react with the NaOH. Okay, so you got your NaOH, your HCl. Okay, so I'll start you off. You've got mass, formula mass, moles, and ratio. Okay, I'm telling you, you're starting with 100 grams of NaOH. You need to find out how much HCl you need to react with 100 grams of NaOH. Okay, your formula masses we've already calculated. I'll fill them back in here. And what I want you to do now is pause the video and fill in the rest of the table for yourself. So pause and press play when you're ready to see the answer. Okay, so I've started to fill it in. I filled in my formula mass, which is the same as in the last question. Okay, to calculate moles, I did mass divided by formula mass. So it's 100 divided by 40 is 2.5. Okay, my ratio is 1:1, again, because there's no big numbers in front in the chemical equation. I just write 1 because these two numbers are the same. These two numbers have to be the same. So I'm going to write 2.5 here as well. And then to calculate mass, it's moles multiplied by formula mass. So I'm going to multiply these two numbers together. 2.5 times 36.5 equals 91.25. So if I have 100 grams of NaOH, I need 91.25 grams of HCl. Okay? I'm going to give you another equation. I'm going to give you Na plus something slightly different. All right, I need to balance this. Okay, I've got one sodium on this side, one sodium on this side, so that's fine. But chlorines, I've got 2 here, and I've only got 1 here. So to balance it, I need to put a big 2 at the front. All right, now I've got 2 chlorines and 2 chlorines, so that's all okay. But I've got 2 sodiums, so I need 2 sodiums. I'm not too concerned about you balancing equations right now. I will always balance it for you, okay? But I balanced it for you. And I'm going to do this question slightly differently, okay? I'm going to tell you that you're starting off with 100 grams of sodium. And I want to use the balanced chemical equation to work out how much sodium chloride I'm going to make. Okay, so let's assume I'm starting with 100 grams of sodium. I've got enough chlorine, just assume we've got enough chlorine. And I want to know, if I'm starting with 100 grams, how much sodium chloride am I going to make? Okay, so for doing this one, into my table, okay, I'm only ever going to have 2 chemicals in my table. Okay, and you're always going to include the one you're given information about. So I'm given information about sodium, so I'm going to include sodium in my table. And the other thing you're going to include is what you were asked about. So you're asked about NaCl, so I'm going to include NaCl in my table. Okay, I'm not asked about Cl2. I'm not given information about Cl2, so I'm not going to include it. The rest of my table is going to look the same as before. Okay, and I'm going to fill in my mass of sodium. I know I've got 100 grams. Okay, I'm trying to work out how much NaCl. I'm going to give you the numbers that you will need for your formula mass. Na is 23, Cl is 35.5. Okay, I'm going to help you out as well with the ratio. Okay, for the ratio, you always take the big number in front. Okay, there hasn't been a big number so far, so we've just written 1. But now you've got a big number 2 in front of the Na. And you've also got a big number 2 in front of the NaCl. So now you've got a ratio of 2:2. If you simplify the ratio 2:2, you can write it as 1:1. Okay, so have a go with the rest of this. Pause, try and fill in the rest of the table for yourself, and press play when you're ready to see the answer. Okay, so I started off Calculating formula mass, probably should have mentioned this, you do not use the big numbers when you're calculating formula mass. So I know there's a big number 2 in front of Na, but I never use big numbers calculating formula mass, okay? So in my actual formula of Na, which I've written here, I've got 1 Na, so the formula mass is just 23. Over here, I'm ignoring that big 2. I do not use it calculating formula mass. And I've just got 1 Na in my formula and 1 Cl. So it's 23 plus 35.5 is 58.5. So that's my formula mass. To calculate moles, okay, it's going to be mass divided by formula mass. So 100 divided by 23 is 4.35. Okay, so I filled in my moles. And now I need to fill in my moles of NaCl. Okay, so I start off with a ratio of 2:2, but then I simplify that to 1:1. So it's the same as what we had above. And what we saw above was that if these two numbers are the same, and they are 1:1, then these two numbers have to be the same. So this is 4.35 moles. This is 4.35 moles. Okay, I've got moles, I've got formula mass, I need mass. It's going to be moles 4.35 times mass. It's 58.5, so 4.35 times 58.5 equals 254.48 grams, okay? If you start off with 100 grams of sodium and you've got plenty of Cl2, you've got enough Cl2 for the reaction to take place, you are going to end up with 254.48 grams of sodium chloride, okay? So you can use these calculations to either figure out how much of each reactant you need, or you can use them to figure out how much product you are going to make, okay? Just do one more just so you can do these for homework and it's not too much trouble, okay? I'm going to give you the same equation again. I'm just going to change the numbers. 2Na plus Cl2 goes to 2NaCl. Just do one more for me. Na. I'm going to use the same equation. So I'm going to use, this time I'm going to say I want to make 500 grams of sodium chloride, and I want to know how much sodium I need to start with if I want to make 500 grams of sodium chloride. I'm going to assume I've got lots of chlorine, as much chlorine as I need, but I'm trying to make 500 grams of sodium chloride. How much sodium do I need to start with? Okay, so in my table, I'm going to put sodium because I'm trying to find information about sodium. And I'm going to put sodium chloride because I'm given information about sodium chloride. I'm not going to include chlorine. I'm not asked about it. I'm not given information about it, so I won't include it. And then I'm going to fill in mass, formula mass, moles, ratio. Okay, I've got my mass of NaCl. It's 500 grams. Mass of Na, that is what I'm trying to find. Okay, you need to fill in your formula mass. The ratio is going to be the same as above. Okay, I'm actually just going to leave it at that. Press pause here and try and fill in the rest for yourself. Okay, so I filled in the formula mass. Na is just by itself, so it's 23. Okay, so the number next to Na is 23. NaCl, you've got 1 Na, 1 Cl, you add them together and you get 58.5, just like I've done up here. Okay, I've got mass, I've got formula mass, so I do mass divided by, so I'm dividing these numbers, mass divided by formula mass, and I get 8.55 moles. To get my ratio, I look at the big numbers for my chemical equation. Big number in front of Na is 2, big number in front of NaCl is 2, so I've got a ratio of 2:2. I simplify that to 1:1. These two numbers are both the same, so these two numbers both have to be the same. If this is 8.55, this is 8.55, okay? So if I'm making 8.55 moles of NaCl, then I need to start with 8.55 moles of sodium because I've got a 1:1 ratio between the two of them, okay? If I want to start with 8.55 moles of sodium, then what mass of sodium is that? It's 8.55 multiplied by 23, which is 196.65 grams. Okay, if I want to make 500 grams of sodium chloride, I need to be starting with 196.65 grams of sodium. Okay, I'm going to give you a few of these questions to do for homework. I will draw the table for you at the start and fill in some of the numbers. You'll just have to fill in bits of it yourself. But then as you move on, I'll take more and more of the table away, and you'll have to fill in as much of it as you can. I appreciate that this is all new. And it is difficult. People find this topic, or students tend to find the topic very difficult. But we're going to be working on these type of problems for the next 2 or 3 lessons. Okay, we're going to get lots and lots of practice of these type of problems. So don't worry if you don't get it straight away. Try and do the homework anyway, and just message me if you've got difficulties. I'm more than happy to help.